right. This one is very exciting because it's a question that is not as obvious as the other ones we've seen before. We're required to determine f prime of x, or the derivative from first principle if f of x equals to a over x. This is the first derivative, by the way, the first derivative from first principle if f of x is a over x. Now that a there is just to tell you that it could have been anything. I could have used 2 over x, I could have used minus 9 over x, I could have used any constant. So I want to work it with a to just show you that it doesn't matter. Whatever the value you have there, the answer is going to follow the same route. So once they say the first principles, the key word here is the words. These words, first principle, mean that we need to use the formula for first principles, which is this one that you're looking at. The limit of f of x plus h minus f of x divided by h as h approaches 0. Now, for us to be able to work out the solution here, of course, we know that f of x, which is a over x, is going to be substituted here, but we need to know what is f of x plus h. So f of x plus h is what you get when you replace your x with h in that particular, with x plus h in that. So it's going to be a over x plus h. So there are no complications there. We can see f of x is a divided by x. Now f of x plus h will be a divided by x plus h, because you replace your x with x plus h. So now we are ready to start substituting those here. That will be the limit as h approaches 0 of this, which is basically a divided by x plus h. There's a minus, there's my minus, there's f of x, which is also a divided by x, and all this needs to be divided by that h on the denominator there. Okay, now the only problem that people have on this question is the fact that they struggle with adding or subtracting, in this case, two fractions. And there's a technique you can actually use that will help you to subtract two fractions. If anybody says to me, what is a over b minus c over d, what I simply do is I just say keep the denominators as denominators. So what I will do is I will say, okay, draw a division line. This b and this d will make up what we call the LCD. You just put them on the denominator. You take these guys to put them here, and then after that you just cross multiply. This times that will give you AD minus this times that will just give you BC. It works all the time whenever you need to subtract or add two fractions. It's just a technique that I use that works all the time. Keep the denominators as denominators. They make up your LCD, and then you cross multiply. Start from the top, and then that one, that minus comes back in the middle there. That will be the solution to that. So I'm going to apply the same idea on my a over x plus h and this part of a over x. So I'll say this is as good as the limit as h approaches 0 of. Now that thing here, I'm going to do it in brackets. The denominator here is x plus h and x. So I'm going to take those and keep them as denominators. So I'm going to keep my x plus h here and keep that x here. And then after that, I'm going to cross multiply. This times that will give you a x. And then there's a minus. This times those guys there will just be a times your x plus h. All right. Now that long division line, I don't like it. I'm going to change it to a division sign and say that is actually divided by h. Okay, cool. And then from here, I'm now going to finish it off here on the side, because we're not going to have enough space if we keep going down. Let's just do this. All right. So now this is going to be equal to the limit as h approaches 0 of, that's ax on top there. Okay, that's going to be minus ax. There's minus ax. And then that's going to be minus ah. Okay, minus ah divided by, don't multiply those brackets, leave them the way they are, x plus h into x. And then it says divide by, so I'm going to change that to multiply and apply the concept of tip and times. We know that h is as good as h over 1. So if I apply tip and times by changing division to multiplication, that's going to be 1 over. So it's going to be 1 over h. And then you will agree with me that ax will subtract ax out. You are left with minus ah divided by whatever that LCD we have multiplied by 1 over h. From here, I can also say this h will cancel that h out. So the only thing remaining on the numerator is just going to be that minus a. So this is the limit as h approaches 0. On the numerator, the only thing surviving is that minus a divided by, on the denominator, I have x plus h, and I also have x there. Now, since that h, this is the problem, that h is the problem. If that h is gone, you are ready now to replace your h as 0. So this is going to be equal to, I'm going to stop writing the limit because now my h is going to become 0. So this is going to be minus a divided by I've got x plus something and another x there. The only thing changing is my h is now becoming a 0. Okay, x plus 0 is x, x times x is x squared. The final answer is minus 8 divided by x squared, and that will be the solution to this question.